All right, so have you ever looked at a big multi-step maths problem and wondered how you're supposed to get full marks? Well, today we're going to crack the code. We're taking an actual GCSE question and breaking it down piece by piece using the official mark scheme to see exactly what the examiners are looking for. Let's jump in.
So, here it is. This is our challenge. We've got a plan of an L-shaped floor, and our friend Petra needs to paint it. She has 3 tins of paint. The big question is that going to be enough to cover this whole area? Let's figure it out.
Okay, the best way to attack a problem like this is to break it down into 2 smaller, much easier questions. First up, we need to figure out the total area of the floor. How big is it, exactly? And second, we need to calculate how much area Petra can cover with the paint she has. Once we've got those 2 numbers, we can just compare them and get our answer.
Okay, let's dive right into part 1, calculating the area of this L-shaped floor.
And here's where looking at the mark scheme is so useful. It actually shows us there isn't just one single right way to do this. It lists multiple, completely valid methods. And that's a huge takeaway. In math, there's often more than one path to the right answer. So let's walk through 3 different approaches that an examiner would absolutely accept. First up, we've got a super common approach. Just split the shape into pieces we already know how to deal with. So just imagine drawing a line straight down from that top inner corner. Boom! Just like that, our tricky L shape is now 2 simple rectangles, a big one on the left and a smaller one on the right. Now we can just find the area of each one.
That bigger rectangle on the left is 8 meters by 6 meters, which gives us 48 square meters. Now for the smaller one. We can see its height is 5 meters. To get the width, we take the total width, which is 10 meters, and subtract the 6 meters from that first rectangle, which leaves us with 4 meters. So 5 times 4 is 20. Add them together, 48 plus 20, and we get a total area of 68 square meters.
And check this out. This is straight from the mark scheme. It confirms this is a perfect method. It says you get a P1, that's a process mark, for showing a complete process, like adding 48 and 20. And this is so important. It's not just about getting the right number. It's about showing your work and how you got there. Okay, that was method 1. But what if you saw the shape differently? Let's look at another totally valid way to do this. This time, let's slice it the other way. We'll draw a line straight across from that left inner corner. Now we've got a long rectangle up top and a smaller one at the bottom. The logic is exactly the same. We're just working with different numbers.
So this time, the top rectangle is 10 meters by 5 meters. That's 50 square meters. The bottom one is 6 meters wide. Its height? Well, that's the total 8 meters minus the 5 meters from the top bit, leaving 3. So 6 times 3 is 18. And when we add 15, 18, what do we get? The exact same answer, 68 square meters.
And yep, you guessed it. The mark scheme backs this up too, listing the 50 plus 18 calculation as another way to get that P1 mark. This is awesome, right? It proves you can use whichever method makes the most sense to you. Different approach, same result, same mark. Now for a slightly different way of thinking, which can sometimes be even quicker. This is the subtraction method.
So instead of adding pieces up, we're going to take a piece away. Imagine a big 10 by 8 rectangle that surrounds the whole shape. To get our floor area, all we have to do is find the area of that big rectangle, and then just subtract the bit that's missing, that little corner. The big outer rectangle is 10 by 8, giving us 80 square meters. That little missing chunk? Well, its width is 10 minus 6, so that's 4, and its height is 8 minus 5, which is 3, so its area is 12 square meters. And 80 minus 12 gives us, you guessed it, 68 square meters.
And for the third time, the mark scheme confirms our process is spot on. Subtracting 12 from 80 is another clear path to that P1 mark. So there you go, 3 different, perfectly valid ways to prove the area is 68 square meters. All right, we've totally nailed the floor area. It's 68 square meters, locked in. Now for the second half of the problem. Does Petra actually have enough paint? This part is a nice, clean calculation. Petra has 3 tins of paint, and each one has 2.5 liters. So 3 times 2.5 gives her a total of 7.5 liters of paint. We're also told that 1 liter covers 10 square meters. So we just multiply her 7.5 liters by 10, and that tells us her paint can cover a grand total of 75 square meters. And, no surprises here, the mark scheme shows that demonstrating this calculation, 3 times 2.5 times 10, earns you another one of those process marks. Perfect.
So now we have our two magic numbers, 68 for the floor and 75 for the paint. We've done it. We've calculated the area of the floor and the total coverage of the paint. Let's bring them together and make the final call. And here it is, the moment of truth. On one side, we have the area of the floor we need to paint, 68 square meters. On the other, we have how much area the paint can cover, 75 square meters. So is 75 enough to cover 68? The answer is a nice, clear yes. She's got more than enough paint. But hold on, this is maybe the most crucial bit. The final mark isn't just for saying yes. The mark scheme gives a C1, that's a communication mark, for stating your conclusion and backing it up with the numbers you calculated. You have to write something like, yes, she has enough paint because 75 square meters is greater than 68 square meters. That's how you nail it and get every single mark. So, I'll leave you with a little challenge. Using the exact same process we just went through, what would happen if the paint wasn't quite as good? What if 1 liter only covered 8 square meters instead of 10? Would Petra still have enough? Rerun the numbers and see what you find out.